So now we've got LDAP up and running on our remote system. We can confirm that it's bound to TCP by executing a netstat ntl grep 389, which is the default port. And there we see 389 is bound to IPv6 as well as 4. If we turn on the P option, it will reveal that indeed slapd is bound in both cases. In the case of the colons, the 3 colons followed by 389, this represents IPv6, and the 4 zeros followed by 389 represents IP version 4. So LDAP's up and running, but how do we interact with the directory? Well, one thing we can do is search the directory to see what objects exist. Now, if you have previously had LDAP set up, then the entries from the previous setup should be reflected by an LDAP search. However, if you have an empty directory information tree, then a search will yield no results. In either case, we can search a directory. So let's move on. Now that it's up and running, let's move on to our next task, which is to search the DIT. Now, there are 2 ways within SUSE Linux by default that we can use to search a directory. There's a GUI LDAP browser that you may access using YAST, and there's the classic LDAP search utility that you may use from the shell, which is included with the OpenLDAP 2 client package. So let's just list 2 ways to search. And they include 1, LDAP search, which is included with OpenLDAP 2 client RPM or package, or 2, using the LDAP browser GUI in YAST. Let's begin by using LDAP search. So, LDAP search. This is the classic tool which is cross-platform ready, which means whether you're running Sun, HP, Unix, Linux, etc., LDAP search, providing you're using OpenLDAP 2, is available. LDAP search supports a plethora of options. However, the most important options will indicate. For example, to perform a generic anonymous search, execute LDAP search -x. Now, the -x option bypasses encrypted authentication, which we have not yet set up. -b, which indicates the base DN, or the suffix that we've defined, followed by the name of the base suffix, which will indicate between double quotes. Now, if your base suffix does not contain spaces or any characters that may be misinterpreted by the shell, then you can omit the double quotes or the single quotes or the wrapped quotes. However, it's always good to be on the safe side and just go ahead and use the quotes, either single or double anyway. Now, our base DN, as you may recall, is DC equals Linux CBT, DC equals internal. That's our base DN. This will allow LDAP search to connect anonymously to the base DN and enumerate any objects found. Now, because we're performing just a generic search rather than a search for a specific type of object, we'll go ahead and specify between double quotes and in between parentheses that the object class can be anything. So we're not looking for an organizational unit or a user or a group. We're simply looking for any defined object that the anonymous user has access to. And by default, we should reiterate the default OpenLDAP 2 configuration supports anonymous connectivity, meaning the ACL permits anonymous connections. So this performs anonymous search for any object in the DIT. Let's go ahead and give this a try from the remote system. And if we're not connected to the remote system, then we should use the host option from the local system to connect to the remote system. But we are indeed on the remote system, Linux CBT SUSE 2, where we'll execute LDAP search. Now, LDAP search, just let's confirm that it was a successful search, despite the fact that no results were returned. Returns no results. However, it was a successful search in that, despite the fact that there were no results, LDAP search was able to connect to the DIT. It told us that it's version 3 of LDAP, despite the fact that the package is named OpenLDAP2. The version of the protocol implemented is version 3. It searched and there were no objects returned. By default, when you configure LDAP, there are no defined objects. So back to our graphic for a second. Nothing's defined. The first object that we're going to define is the root object or the domain object for DC equals Linux CBT, DC equals internal. We have defined a reference point for the slapd server to serve the context DC equals Linux CBT, comma DC equals internal. But we actually need a container, and we'll create that container momentarily. Now before doing so, let's show you the second way within SUSE, and if you have the GUI tool available within your distro that you may search. So the next way would be to use the LDAP browser. And this is accessible through YAST. So let's launch YAST. This will prompt us for authentication as we're not logged in as root. And once it's up, we'll navigate to the network services area. And there is a section which contains 3 LDAP icons. One is a browser, the other is the client, and the final is the server. By clicking on the browser, it'll prompt us to authenticate. Now we're executing the LDAP browser on the local system. Notice above where it reads YAST2 at Linux CBT SUSE 1. This means we need to specify the remote server's IP address or host name. So let's go ahead and just note that. We access this utility via YAST network services LDAP browser. And we should authenticate using root DN. Now the root DN we defined above as CN equals manager, DC equals Linux CBT, DC equals internal. And we know the remote system's IP address, so we'll go ahead and indicate it as 192.168.75.19. And by the way, if DNS is operational or your host's file resolves the remote system by name, by all means use the name. You can test that from the shell from the local system, of course, from Linux CBT SUSE 1. Let's see if we can ping sending 3 packets to Linux CBT SUSE 1, SUSE 2 that is, and notice no response. And that's a response from our level 3 provider. How about using the fully qualified Linux CBT internal? Ditto, doesn't know who it is. To rectify this situation, we'll SU in and modify etc hosts. And that's hosts plural. We'll then need to create an entry for Linux CBT SUSE 2. So we'll just cut and paste the entry for SUSE 1, updating the IP address to be 19, and updating the fully qualified and short names to be Linux CBT SUSE 2. Now we should be in business. We'll try to ping, sending 3 packets again to Linux CBT SUSE 2, at which point it works, which means back to the LDAP browser we can update this, but we'll connect first using the IP at layer 3 of the OSI model, and then using the name at layer 4. So we've got the administrator DN or the root DN. Administrator DN is one and the same. We should just note that. Or administrator DN. The difference with the terminology administrator DN is that once you become very familiar with LDAP configuration, you can define groups of administrators, or at least one group of administrators, and those users or those members will have administrative rights. So administrative rights isn't necessarily limited to a user called the root DN or the manager user per se. By default, without any defined ACLs, root level access to the DIT is indeed restricted to the user manager. The LDAP server password. This is the password we configured on the server in slapd.conf. Let's just navigate to etc open LDAP once more, and we'll grep root pw from slapd.conf, where you'll see the uncommented root pw is abc123. So this is what we'll specify here. We'll click OK, and there you see the base suffix. It contains no objects, no root objects, but this is the base suffix. If we double click, Nothing happens. We see no hierarchy. We don't see a full tree because only the suffix is set up. This is the suffix, the base DN, the base distinguished name, the root that's being served by the LDAP server, but there are no containers. And before we can create organizational units for our general purposes, we need to create at least one organizational unit which represents the domain. And that will indeed represent this node, the gray icon that looks like an Active Directory root. So we'll be creating this root container momentarily, followed by the remaining organizational units. Now, if you want to use the LDAP browser to modify the directory information tree, navigate to entry data for a given object. But in this case, since there are no objects that we can modify, we're unable to do anything. There are no attributes and no values defined at this particular point. When we create the base DN followed by one or more organizational units and one or more users and groups, we'll then be able to use the LDAP browser to make changes graphically. If there have been changes during your run of the LDAP browser that you need to see reflected in the browser, click on Reload. It doesn't auto-reload. Reload will reread the LDAP database and display the latest directory information tree. So since nothing exists at this particular point, let's close the LDAP browser for a moment and proceed to using the LDAP add utility to create our directory information tree. So that leads us to our section where we focus on the DIT creation. So in our notes, next step is DIT creation. And the task is to create a DIT which resembles our drawing, which means a root DN or a root base, a base suffix that is, or a base DN, not a root DN, a base DN. Root DN is the user who has full access, so a base DN followed by one or more organizational units. Now we'll just work from left to right. We'll create this base DN. This is the domain. Then we'll create the people OU, followed by engineering, sales, and then we'll populate users into those organizational units. Again, the hierarchy in LDAP is maintained via organizational units. Everything's stored within an organizational unit. Now the first thing we want to do is build the root OU. And we've created an LDIF file to save us some time. So create, this will be our root OU or container. Let's go ahead and open in a separate tab the file that we've created. Now, our files are actually on the LDAP server, Linux CBT SUSE 2, so what we'll do is examine them from there. We have an LDAP directory created, and we have a file named build root ou.ldif. Let's cat the contents of this file and copy and paste this into our notes. Again, the LDIF files are available in your docs subdirectory. So in a new tab, we'll paste it and just discuss the contents of this LDIF. LDIF files are important to understand, so let's go through the syntax. So we'll create the root OU container using a predefined LDIF file. In this case, it's build root ou.ldif. So here's the text from that file from the server. To build a root node, we need to define some key attributes. Remember, we mentioned attributes are fields. DN is an attribute, DC is an attribute, object class is an attribute, OU is an attribute. We need a container which will contain all the other containers. That's the root node. That's the root OU. That's the domain. linuxcbt.internal. Its attribute, DN, is DC equals linuxcbt, DC equals internal. This is how we define the root container. The domain is simply, or the DC, is simply linuxcbt. The object class is DC object. but it also has another object class. This is a way that we can facilitate inheritance. DC object describes some fields, whereas organizational unit describes other fields. By combining the two object classes into the descriptor for this particular OU, we in effect make the OU, or the container, like the two object classes. So this container will be both a DC or domain object as well as an organizational unit. So again, looking at our graphic, this container is treated specially because it will inherit the fields from, or attributes from, two distinct object classes. One is organizational unit, the other is a DC object. And then last but not least, we have a descriptive name, OU. These are the required attributes when building a root node or a domain node. We need a distinguished name, a domain name, which is like a short name, at least these two object classes, one indicating that it is a domain object, another indicating that it's an organizational unit, because indeed it holds other organizational units, and a unique name for the OU, which we simply create based on the two separate names for the distinguished name. It doesn't have to be, it could be called anything else, but just for consistency, we've concatenated the two names that constitute the DN, or distinguished name. Now, in order to effect the changes of this file, what we'll do is navigate to LinuxCBT SUSE 2 and execute LDAP add. So LDAP add followed by the right options, followed by the name of the file, will cause the file to be imported into the directory information tree. So this is our first use of LDAP add. Now, whenever using an LDAP command, you should specify the -D option followed by the user with whom you'd like to authenticate to the directory as. And that syntax is usually the full CN, or the full distinguished name, which includes the CN of the administrative user, or the root DN in other words. We know the root DN to be CN equals manager, and again we mentioned the common name is case insensitive. DC equals LinuxCBT, DC equals internal. This is the unique name, or the distinguished name, of the administrative user, the root level user. So with most LDAP command, this is the syntax. This is the initial syntax. LDAP command -D followed by the root DN. This is standard syntax. What follows are other syntaxes that are shared and some that are unique to the command that you're executing. For example, we'll indicate that we're to be prompted on the command line for a password by indicating W. If you use lowercase w, then you should specify the password to follow, such as ABC123 or quote ABC123 or space quote ABC123. We'll elect to use W, which causes LDAP add to prompt us so that the password isn't saved within our history. We'll use the -X option, lowercase x, an important option when you don't have security set up. This bypasses that security, and it does so by using simple authentication. So that's the whole idea behind using the -lowercase x option. When we have encrypted authentication set up later on, then we'll cease using the -lowercase x option. The final option is -F. -F is common, as well as so are -X and upper and lowercase w's to all of the LDAP commands. -F simply means process the lines from the file which follows. So -F build root OUs.ldiff. And let's just confirm the name on the remote system. And it's actually build root _OU.ldiff. So let's just recap. We want to add the contents of build _root _OU.ldiff by authenticating as the root DN using W, which means prompt us for a password, lower x, which means use simple authentication, to the directory information tree running on the remote system. And what will be processed is what we see here. The first line is ignored because it's prefixed by a hash mark. We want to create the following distinguished name. It is a domain named Linux CBT, and it wears two object classes, domain object and organizational unit. So it's a domain and it's a container. And we have a descriptive name. Every item within the directory needs a descriptive name for its type. Let's try to execute this on the remote system. Again, this will prompt us. Now if we indicate the wrong password, invalid credentials, a non-zero exit status is returned. Let's try it again. And in fact, let's just execute LDAP search to be sure that this indeed worked, meaning it didn't commit the changes. And as you can see, the directory is still empty. So let's try it again, this time specifying the correct password. And notice what's returned is that a new entry was added for DC equals Linux CBT, DC equals internal, and an echo of the exit status returns 0, which is what we expect. Now let's clear the screen and rerun LDAP search, where we'll now see the new object. There's our first object, DN, DC. It wears two object classes, and it's an organizational unit, which now means, back to our graphic, we finally have this container. Of course, the LDAP server knows to serve the DC equals Linux CBT, DC equals internal domain, but it actually needs a container which will then contain the other containers. So that's now in place. Now we need to make some more changes. For example, we should create the top level organizational units. So create organizational units that we will use. They include people, engineering, and sales. And in the interest of saving time, rather than defining the LDIF on the spot, we have created the files which will allow us to add the OUs. Now we have a file, add_OUs, and this particular file adds engineering as well as sales. We can take this file and add people as well. We also have broken out the addition of the OUs into separate files, such as build people OU. So cat build people OU, for example, shows what's required to build that particular OU. Here's an OU equals people. We've even got users in there as a separate OU. And this file has sales and engineering. But looking at our graphic, what we want is to create people, engineering, and sales. So what we need to do is take the best from these two files and compose a new file. Let's take engineering, and we'll take the comments as well because it helps us with executing or remembering how to execute the commands. So we want engineering and sales. Let's go ahead and take that out, copy it, and paste it into our gedit window. We'll erase this info. And we want also the people OU from the other file. And then we can discuss what's happening here momentarily. Let's just place them in order in which we see the OUs on the screen. So I've got two commands up top which are commented to serve as reminders. It always helps to have this sort of info. So we want to create a new distinguished name. Its name will be people. Beneath DC equals Linux CBT, DC equals internal. Its name, its OU name, will be people, and its object class will simply be organizational unit. It will not be a domain like the root or base DN. And ditto for engineering, ditto for sales. What this tells us is this is the standard syntax for creating organizational unit containers. So if you desire to script this out for mass production, for example, follow this syntax and just variabilize the portions that need to be variabilized, such as OU equals variable, OU colon space variable, and the rest should fall into place. Now let's save this. We'll save this, which of course is on or in the docs directory, as add 3OUs.ldiff. And we can copy this over to the remote system either using SCP or simply copying and pasting into a file on the remote side. So we'll nano add 3OUs.ldiff and then right button paste the creation of these organizational units. Now if there's a syntactical problem with any of the objects during creation, the LDAP add command will fail by default. There is a way to bypass failures. However, the default is to fail if an error is encountered. So let's go ahead and try to create these OUs. Similar LDAP command, but this time we specify a different file name. That's all that changes. So we LDAP add, and instead of build root OU ldiff, we reference add 3 OUs ldiff. And again, if there are any errors, it will fail. The creation of the objects will fail at the point with which the error was detected. So again, let's just execute LDAP search one more time. This is exclamation LDAP search, which in the bash shell references the most recent invocation of LDAP search. And as we can see, there is one object, the domain container, the top level container. We've yet to create the 3 org units. And the LDAP browser ditto. Let's authenticate, this time using the host name. Linux CBT SUSE2, we can use the short name, CN equals manager, DC equals Linux CBT, DC equals internal, followed by the appropriate password. And as we can see, there are no organizational units. Now, let's return to the shell and attempt to create the 3 OUs. Notice, adding new entry, adding new entry, adding new entry, which means an echo of the exit status, $question in bash or corn returns 0, which now means in addition to the base DN or the domain container, which is what the DC is, we now have 3 organizational units. Those 3 OUs, again, just to recap, do not inherit both types, DC object and organizational unit, but rather inherit the attributes from organizational unit only. Let's clear screen and rerun LDAP search, which is somewhere in our history. And now we see we've got 4 entries: the domain container and 3 organizational units: people, engineering, and sales, which reflects our graphic. People, engineering, and sales. And they're returned to us not alphabetically, but in the order in which they were created. So now we've got our base entries. We've created a root OU or container, which is basically a DC, a domain container. We've created 3 organizational units to store users and groups. And now we're at a point where we can create users within those organizational units. And again, in the interest of saving time, we've already taken the liberty to create the ldiff files that help us to add these users. We've got add second, third users, we've got add users, and we've got first user add. Let's cat add users, and here we see it adds multiple users, multiple engineers. These are for later studies. Let's cat first user add, and this is a simple add. So let's take the contents of this particular add and analyze it in a new tab. So how do we add a user? What is a user based on? Which schema? Which object class? An object class ties back to a schema. Users are based on the object class inet person. inet.org person. Let's just note this. So the third task is to create some users. Note, users are based on object class inet.org person. inet.org person is a schema. If you recall, let's grep inet.org from etc open LDAP slapd.conf. Notice the include of the schema inet.org person.schema. This is an international standard schema that you'll find throughout or across LDAP implementations. It contains the requisite attributes, or it contains the common attributes used in LDAP environments. So rest assured knowing that the majority of the fields that you'll need to create standard Linux, Unix, or Internet type users, which includes email addresses, mobile phone numbers, room numbers, all of the common fields that you could want are in the inet.org person object class, or it comes from that schema. No need to create a new schema, but of course, if you need to extend the schema, you can. Simply open up a schema file and make your changes, but you're always warned against or cautioned against doing that, because then things become proprietary. So quick perusal of this file. We can use LDAP add to add this user. Every user has a common name. So here is my name. Every user belongs to an organizational unit. So I will belong to the people OU. And every OU belongs to a domain container. So as you can see, right up the hierarchy, back to the graphic, user Dean, which we have as user Linux CBT, but user Dean, and I'll change it to Linux CBT, will be created beneath the people OU, which is beneath the domain container Linux CBT.internal. So just to be consistent with the graphic, let's change the common name from this name to simply Linux CBT. We'll make it 1. And then the common name will be Linux CBT 1. The surname will be user, and so on. Let's change the address to Linux CBT 1, etc. So here we've got some key fields. Now, not all of the fields are required, but we certainly need a distinguished name. We need a common name. Surname is optional. Mail is optional. The URI is optional. Room number is optional. Department number is optional. If you're wondering, how do you know which fields are required or not? Just like with any DBMS. Well, just like with any DBMS, unless you know the schema, try to add the user with the fields that you think are required, or with the fields that satisfy your requirements. And if there's a schema violation, LDAP, add, modify, delete, so on will warn you. But it is, by and large, common sense. So we indicate the attributes that are of interest, and then we use LDAP add to add the user. So let's copy the contents of this file and update the other file. So we'll nano first user add. We'll remove everything from here and paste in this new user. Save the changes, and then use LDAP add to add the user, just like we did before. And you should notice a pattern developing here. The commands are almost identical. Same LDAP add, but we reference a different file name. And this will be for the file first user. Let's just copy it so we don't miss it. And that's for first user add, or first underscore user underscore add.ldif. This will add that first user. Clear screen, paste, force to authenticate, adding new entry. Now you may be wondering, what if we try to add the entry twice? Well, let's try it. This time we'll indicate the password on the command line using w, lowercase w, followed by abc123. Notice the entry already exists, so LDAP was unable to add the user. Now let's execute the most recent invocation of LDAP search, where we'll see that there are now 5 entries. There is a user who belongs, a user named LinuxCBT1 who belongs to the people OU in the hierarchy, and the people OU in the hierarchy belongs to the domain container LinuxCBT.internal. And here's that new object. So we're slowly but surely populating our directory information tree. We have created so far the root or base DN, the 3 organizational units, and 1 user. We're well on our way to migrating our system to an LDAP base setup. So next, we're going to continue focusing on creating users in an LDAP environment. We'll continue populating the directory information tree as we study, and then once we have the DIT where we want it, we will set up our other systems to replicate with the primary LDAP server.